Welcome. Today we're going to be taking a look at the set operations of databases, and so let's go ahead and take a look at what we have to do to work with these. We want to talk about some of the actual vocabulary we're going to be using as we go through this process. So the vocab we need to use when we're talking about set operations is a little bit different. We have 5 words we're going to be working with. We have intersect, minus, union, and union all. Those are the vocab terms we're going to be working with as we go through and work with the idea of set-based operation. When we're working with a set operation, it's a little bit different. When we've been doing the idea of our joins we've been working with so far this year, we've been working with the idea of the columns. We take the column out and we work with that as a columnar value that we're working with. However, when we're talking about set operations, we're matching the rows themselves, so that's a little bit different. So instead of taking out the actual columns and caring about the column itself, we're taking the rows, making sure the type and the positionality match. Now, when we're talking about set operations, we do have to make sure that all the column results need to have the same order and type. So if it goes number, string, date, the following set operation tables have to go number, string, date as well. So whatever we're working with, whatever we're selecting out of a query and working with, when we're talking about set operations, we have to have the same type and number and order as both sides of the equation. And so date text is different from and incompatible with text date. So you have to make sure you have the correct type and the correct order. That's something you have to always really watch for, because otherwise you're going to get lovely errors with that. You do also want to make sure that you have the right values in there, because if you have simply just the matching type but the wrong data, you get some embarrassing results. We really want to avoid that. So just as an FYI, keep that in mind. Now, order of operations is pretty much kind of a big deal in everything we do in computer science land and in math land. And so with set-based operations, we're going to do everything that's on the top and work from top to bottom. So it's like, oh, I'm going to do this query, then I'm going to do this query. So I have to make sure it works within that. If you do need to work with something that's going to be handling a specific order of operations separate from that, use the magic power of parens, because like with, say, for example, a subquery or something like that, you can do all that work first and then come back in and do that from there. So just keep that in mind. We have a quick visual representation of our different set operations. This might be something you've actually seen before in the past from one of your other classes. And so we have our first one, table A, union, table B. We have our union all, which is the same thing plus dupes. And then we have minus, intersect, and minus again on the opposite side, so we can see what those are. We'll go ahead and take a lot more detailed look at these as we go through these next few slides. So union is both halves of the Venn diagram. So it's like both the left side and the right-hand side, as well as the middle. So when we're talking about a union, we're getting the entire data set we're working with between the two tables involved or two queries involved that are being combined together in that set operation. So it's a combination of the rows from the first table, or whatever columns you're working with in the first table, as well as the combined results of the second table. And so you want to get all the names of your students and all the names of the teachers together, and you want to sort that, because it's amazing what that happens. As it goes through and adds it together, we're only getting the exact matching values, and it sorts them all together. It's a great thing. Now, so that's the idea of working with the union operation. Some examples of that would be like combining the favorite movies of teachers and students, the worst dinner item of both kids and parents, the favorite color and movie of group A combined the least favorite color and the hated song lyric of group B. Because again, we can combine things as long as it's the same type, we're good to go to combine that information. Union all is the same kind of thing. As you can see, we have table A, union all, table B. It's all those plus we get the duplicate values. So if there's anything shared in between that, if there's any multiple values of the same thing, we're going to get all of that too. So it's not quite as useful. So union all is the idea of union with no sorting, includes dupes, but it's only really useful for making a compound insert statement. That's the only actual use I've found for doing it. I know, crazy. Union all examples, you want to ask some questions that have a guaranteed amount of duplicates, like, oh, what's the favorite food of everyone in the class? You're going to get at least some people say the same thing at least once. What's your favorite color? Probably the same thing again. And what we ate for lunch, especially if you're at the same facility, there's a really good chance that everyone had more than one thing that was the same. So great way to do that for union all is you're going to get the same results plus dupes, and there's no sorted to it. Minus. Now minus is the light pink side over on the right or the light blue side on the left. So it's table A minus table B. So it does not include the magenta section in the middle. It's just the blue or the pink, not the combined values. And so when we're talking about minus, it's just the C-shaped or the backward C-shaped or the crescent moon-shaped part of the Venn diagram. And so it's the partial side circle, none of the middle. So nothing in the middle is going to be shared. I want to get only the ones that are in one table and not shared with anyone else. And so the order of the tables actually matters. So query A minus query B is different from query B minus query A. And so you can easily see that when you look at the idea of what you're looking at in the actual Venn diagram. So that's what we're doing as we look through that. Minus examples. What is a characteristic that's shared by Batman but not Spider-Man, using a popular culture reference? What rights are listed in the Universal Declaration of Human Rights that are not shared in the U.S. Constitution and associated amendments? Or what features of the Honda Accord are not shared with the Honda Civic? Again, we're taking a look at, here's the column, this thing, and I only want the ones that are on this side or only ones that are on that side, not the shared values between them. So it's a great way to do some great logical questions. Intersect is the idea of that middle section. That's the thing that are shared in common. So it's like, oh, I have things that are in A and in B, but not the ones that are only A or only B. So it's just that tiny little section shared in the middle between them. And so this is the same thing as an equijoin. However, it's matching columns again, because we have to make sure we have matching row values on this instead of matching column types. And it sorts the results, which is always good. However, there's no PK-FK relationship. What? No PK-FK, no primary key, no foreign key relationship. This is just combining results where they share the same data type and column type. That's all we're working with. So if you want to combine results without a PK-FK relationship, intersect is the way to go, not a join on some bad random join. Okay, so intersect is how I get those information without using the without using a primary key foreign key relationship, so I can combine table results together without the PK-FK structure. So that's why we want to use this right here. What are some personal qualities in common between the protagonist and the antagonist? Or some generic English language arts reading assignment right here. This is something you've done so many times from the time you're in junior high, high school, college, whatever. This is something you've done a lot. So intersect is a really common question you have to ask, and it's a great way you can do some stuff using a database to make that happen. So as we finish off right here, let's take a quick visual representation of the set operations again. If we want to get everything involved in the two tables that match the column or both structure and position, we use the union operation. If we want to get everything plus some extra, we use the union all. And then finally, if we're talking about only one side or another, we use the minus operation. Or if we only want the shared information, the A area in pink, we want the intersect operation. I hope this is a great review of the set operations in database land. Hope this is helpful for you. Cheers. See you next time and have a great day. Bye-bye.